I've been invited along today by the Essex Employment and Skills Board to talk about Internet of Things, artificial intelligence and big data. As I'm sure you can appreciate, these are big subjects of their own, so we could have 3 separate talks about these, but what I'm hoping to do is give you an overview as to what they are and how they're already entering lives, the opportunities that are there, and actually what's going on in the market. Big data, as it suggests, isn't really what you associate with Excel. It's enormous data sets. So Excel, if you ever fancy trying it out, can hold about 1 million rows of data, but past that it will just begin to grind to a halt. And so big data is an area where we start to take data from different sources, combine them together in order to create different analytical tools and ways of working things. One of the questions that starts to come from all of this is, well, where are all these enormous data sets and where is all this enormous data coming from? And the simple answer to that is us. We have more and more access to tools and people have more and more access of ways of generating data. I mean, even from today, even myself, I took a photo coming into the business school, which I'll probably tweet, and that's data that's going up onto the cloud. But to give you some idea, there's a recent article in Forbes, and Google now processes more than 40,000 searches every second. In social media, every minute, there's 527,000 photos uploaded. You start to get an idea of where all this data is starting to build up and come from. The issue we have with it is, how is this going to be handled and how is it going to be used? And then there's also the Internet of Things side of things, which I'll come on to later, which is generating a lot of data in itself. So I also believe as well that the big data boom has had a lot to do with the reduction in the cost and the physical side of storage. So we probably all remember these, 20 years ago, this was the de facto way of storing data, your 1.44 megabytes of information. So just zoom forward 20 years, and this isn't cutting edge, this is a 32 gigabyte flash card. Well, this holds the equivalent of 22,222 floppy disks of data just on that side. So that's a clear indication to people, developers that are starting to work in this area, that actually I can store an awful lot more data for a similar cost. So this is, £8 from Amazon. That, along with all of us creating more data, has created an environment where big data and more data sets start to form, and there's actual value in those data. So we're probably all aware of the Cambridge Analytica Facebook scandal, but this gives you an idea of the kind of the big data and the vast amounts of data and what can actually be done with the data. So an alleged 50 million private Facebook profiles were harvested over the span of a couple of months. So it's not any time at all. And this was all gathered from an app, the personality app game that appeared on people's Facebook profiles, and people filled it out for a bit of fun. And one of the conditions in it was that you would share your data that you put into the app, and less well known was, in small print, it was also of all your friends and associates. The data was used to understand what would need to be done to pick up people's mental and emotional vulnerabilities so that they could then be manipulated and behave in a certain way. And the data that was harvested for this, they've now shown was actually used to influence the 2015-2016 Donald Trump and Ted Cruz campaigns, the 2016 Brexit vote, and the 2018 Mexican general elections. And they're the ones we know about, this data and the tools and the manipulation on that side. But I'm, oddly enough, an advocate for big data, but this shows how there has to be securities and things thought about before data is just randomly used on that side. So let's go to a more positive side of things. I think most people have heard about the mapping of the Human Genome Project. So again, this is an example of using big data, and it's regarded as one of the most significant advances in the history of medical research. And by using the big data techniques now we're actually able to lower the cost of sequencing. So when they first started doing it, the projects, well, when they got to the end of the first project, was £2 billion. Now you can have your genome sequenced for £2,000, and instead of it taking a decade to sequence your genome, it can be done in a week. And this can be used for advanced medical diagnosis and advanced medical treatments on that side. Probably closer to home, Netflix uses big data, and one obvious way you'll probably be aware of is when you're going through Netflix, it will suggest other good titles, other films that you might want to see. But Netflix moved away from using data reactively, so gathering what information was, and started using it proactively. It took 6 years for Netflix to collect enough data until they were confident that they had all the ingredients they needed to make a hit show. They analysed the big data, and the show that came out of their first big data trial was House of Cards, which most people know and heard of, and was a huge success. And they've gone on and replicated this. One of the statistics is 80% of their shows have a higher hit and hit rate and audience acceptance than the remainder of all the other productions that are put out by different broadcasting companies on site. So using that model, and where we click or like a certain bit of a film, or there's a certain characters in a film that draw people towards, they've used those little bits of data to actually create programming and information that viewers like. Again, you can see that as a sinister side, but then you can also see it as a positive side. If you took that over to the educational system and lessons and lectures that are given, data from programs and talks that are given, hopefully this will be one of them, can then be selected and put together to actually produce content that's more readily available and absorbed by students and the audiences on that side. Whenever you talk to someone in big data, they mention the 3 V's, and just because it's technology, there's actually 5 of them. So, but the main things that are used to gauge big data are volume, velocity, and variety. So volume is just simply the way data's coming in. So with Excel, it's very much batch processing. So you might have students' exam results, or you might have sort of financial information. So this comes in quite slowly, and you're able to handle it quite well. But when the information starts coming in at sort of sub-real time or actual real-time level, as in data's being generated that second, that moment, that starts to be one of the factors that starts turning the data into big data. And that, again, that's purely because the amount of data that you will generate being real time will be far greater than just simple batch side of things. Then there's the amount of data that you're collecting. So that can be from sort of traditional, more Excel side of things with megabytes level, but actually instead of megabytes of data, you've got petabytes of data, so huge quantities of data that you've got to try and trawl through and process. And then there's the variety of data, and this is a big area for big data. With Excel and databases, that we're all used to, the data is normally very structured. So again, finance is all sort of decimal point level. You're dealing with percentages, or you're dealing with sort of integer values. With big data, it's far more unstructured. So you could be dealing with a tweet. So you've got a bit of text and a photo, but you still want to be able to process and harvest this information. When people are looking at big data and talking about it, they normally refer to this model to analyse whether it is big data or not. There's also the value, so what value does the data have? Although I have a bit of an issue with that, because with a lot of data you do know the value of it, but it's not until you process the data that you know its value, if you see what I mean. So I find that a little bit of an odd one to add into the big data side of things. The veracity of the data is the actual quality of the data that you're getting. So if you've got a lot of bad quality data, you're not going to end up with a particularly interesting result. What we're finding is traditional tools and software just weren't able to cut the mustard when it came to big data. So the real advances have come in the latest years with frameworks like Hadoop and Spark, and languages like R and Python. Now I realise this is starting to get proper technical, but Python is, I think, the one that should ring chords with you, because Python is used on the Raspberry Pi and in hobby clubs and in schools. So it's a really important language that actually if students or people changing careers or so forth are looking to try a programming language, something this versatile can have you running applications and demos on a Raspberry Pi, but actually working on big data projects, which is really quite exciting on that front. And the jobs really vary. So data architects, database managers, data scientists, so that's a fairly new academic study that's grown up literally in the past 10 years, but is a really highly sought after qualification. Obviously, when you're analysing this data at a high level, then that kind of commands more experience or academic input, but actually just how you're going to store and manage the data also needs to be considered. The thing to take away from the big data side of things is that there's a lot more data being created, and from this there's a lot of value that is obvious from the data, but there's a lot of hidden value that can be taken out.